Welcome class to our next lesson on transmission internals, and this is where we will be going over clutches and bands. These are the apply and holding devices in our transmission. This is how power is transferred through the transmission through our planetary gear sets by using multi-disc clutches or bands or roller clutches to hold and or transmit power through the different members of our planetary gear set. Basic objectives, we're going to be learning about the components of a multi-disc clutch and describe how it operates. We're going to identify the different components of a one-way clutch and describe its operation. We're going to discuss holding clutches and bands and explain shift quality. When we're talking about driving and holding clutches and the difference between those is important as we go through this lesson. There are multiple paths of power flow through an automatic transmission. These are our gear ratios. If you remember the little video on manual transmissions, as we shifted the transmission, the arrows would demonstrate where the power flow was going through. We get the same thing in an automatic transmission, but instead of using two parallel shafts, we are using planetary gear sets. And as we've seen from planetary gear sets, depending on which member we hold, which member is our input, and which member is our output, determines what gear ratio we have. And we're using these bands and these clutches to determine where the power flows through that planetary gear sets. These clutches or bands can be driving or holding members. The driving, often called apply members, and the holding are called the reaction members. Remember, if we think of our planetary gear sets, we are going to hold one member and we are going to drive another member. So one member, the input, is your drive or your apply, and that is the power source coming from the engine into the transmission, goes through a clutch pack. Essentially, we apply a clutch pack or a band which drives one of the members of our planetary gear sets. Then we use a clutch pack or band to hold another member, and then our third member of the planetary gear set is our output. Here's just a quick picture of a basic idea of a multi-clutch disc. You have steels and fibers, and we'll talk about all the different parts, and they'll go down to your clutch hub, and when that's applied, it's going to hold one of those members of this planetary gear set, and then drive power through. Another member is going to be held, and the third member is going to be the output. The apply devices, the driving devices, connect the turbine or the input shaft from the torque converter. Remember the turbine and the torque converter. This is the member of the torque converter that's not connected directly to the case of the converter. That is actually allowed to freewheel inside the converter, and that's directed to our turbine shaft or our input shaft. And once the torque converter starts coupling, it directs power from the engine, from the turbine of the converter through the input shaft. and then that power is then directed into the transmission through clutch packs and bands and through the gear sets. Okay, and then the holding devices, these lock or connect a member of the gear train to the transmission case. That's how they're able to hold that member, by a band or clutch pack that is linked to the transmission case. Then we're able to hold and lock that member. The typical holding and apply devices are your multi-plate clutches or clutch packs, bands, and one-way clutches. We've already talked in starter drives. We've talked about how one-way clutches work, and we'll talk the overrunning clutches on an alternator, and we're going to talk a little bit more on those in transmissions. When we're talking about our multi-disc clutch packs, these are the most commonly used apply or driving devices in a transmission. They can be used for holding, but most commonly used is the driving device. They prefer those over bands because the big thing is multi-disc clutch packs have more friction area. If you remember Pascal's law, when we apply hydraulic force, the larger the area that we're applying it to, the more force. We can transfer that to our clutch packs. So as that force we're putting on the piston, which we'll talk about how this works in a minute, that force is transferred to the disc. And so the discs in a clutch pack have more friction area, so that area can develop more force and can handle more torque than a band. All right, now we're going to talk about the different components of our clutch packs. We'll go through some of these components much deeper as we go through these lessons. Some of them are relatively self-explanatory, but the first one is our drum. This is essentially the housing of the clutch pack. The apply piston, this is where fluid pressure goes on the back side of this piston. There's seals on this piston, so the fluid pressure doesn't leak by. This apply piston sets in a drum, and that apply piston is what pushes out and compresses our plates to turn the clutch pack into a holding or apply device. And then the piston return springs, that does exactly, it's kind of self-explanatory. There's springs in there that are designed to help push the piston back into its resting state after it has done applying the clutch pack. And then we have the plates that are in the transmission. Our unlined or steel plates, our lined or friction plates, sometimes called fiber plates, our apply and backing plates, and then snap ring. It has to be a snap ring that holds all that stuff inside in the drum itself. Here's a picture of that. As you can see, the clutch drum and all those components that will slide into the drum. We have our piston. There's sealing rings on the piston. In most cases, you're going to have an inner and outer seal on the piston. We don't want to lose that fluid pressure. If we lose the fluid pressure, then we cannot apply any force to that piston and thus apply the clutch pack. Most of the time, these seals are on the piston, but there are some times where you might have a seal on a piston and then another seal in the drum. If you have something like that, you'll have an outer seal on the piston and then an inner seal in the drum to seal this from any hydraulic leaks. You'll see your steel plates and your friction plates with they're calling it a pressure plate here. That is most of the time called a backing plate, and we'll talk about that here in a little bit. And then there's your snap ring that holds the whole assembly inside your drum. There is going to be another snap ring. If you see the piston, excuse me, there's going to be a springs assembly on top of that piston. In most cases, there's going to be a snap ring that holds that spring assembly in the drum, which holds that piston in place. Then you'll put your clutch packs in, your backing plate, and then your snap ring, the big snap ring on the outer side. That's what holds your different clutch discs and your ply or backing plate in the drum. But there will be a different snap ring, it's not listed here, that holds the spring and piston assemblies in the drum also. If we're talking about clutch plates, we have our unlined and lined plates. Unlined plates are most commonly called steels or steel plates. These are flat plates, usually about 70 thousandths to 100 thousandths thick. Most of the time the lugs will be on the outer diameter of the steel plate, and those are meant so they'll lock into the drum or the transmission case. So when the clutch discs apply, we have something that it can lock against. So it's either going to be, those lugs are either going to spline into the drum or transmission case, depending on if it's a ply or holding device. The line friction plate, the friction plates, often called also fiber discs, fiber plates. These are steel plates with friction material bonded to them. But the engagement lugs or the splines are on the inner diameter on most clutch packs. And they're usually a little thinner, 63 to 86 thousandths thick. But those are the differences. They're both flat. The steel plate has lugs on the outside, which lock it into the drum or the transmission case, and the line plates have the splines or the lugs on the inner diameter, and that's what is used to lock to a gear or a rolling clutch, another drum, to drive that or hold that device. On our friction material of our friction plates, this lining material can be like smooth and flat, or it can have grooved friction surfaces. Usually if it's smooth or flat, these are clutch packs that are engaged in the static position. In other words, the vehicle's not moving. You put it in gear, these clutch plates apply. That's the most common place you will find smooth clutch discs, fiber clutch discs. Not the only place, but the most common one. But if they have a grooved friction surface, that's usually used on clutch packs that get applied while the vehicle is moving. That grooves in those friction material allow fluid to flow through. It helps while it's applying. It keeps it cooler, because remember, we're taking friction devices and pushing them against steel devices. That's going to create heat, and the friction as they apply, and that fluid is meant to go through those grooves to help smooth that application, cut down on the heat that's produced. It's like a lubricant in this apply process. The most common material is a paper type material. It's going to be on almost all your OE, your original equipment transmissions, where a Kevlar, which is a synthetic material, is used in a lot of your heavy duty or performance applications. Now, this is pretty general when we talk paper, Kevlar, because there's other material that they add to this that changes the friction ability or the holding or grabbing ability of these materials. These would be, you might call the base. Because whenever we're dealing with friction material, especially when you get in the aftermarket performance, a lot of times they'll gauge their quality of their friction plates by what color they are. So you could say, well, that's a red plate or that's a blue plate. So those are going to hold better than a gray plate or a brown plate. That is just kind of there's no standardized rating on those. If you get into high performance applications, that's where you're going to have to do some research. What is the best plate for what you're going to be doing? How much horsepower can I put into that clutch pack or that transmission? But for the most part, if you're doing this for a shop, if you're get into rebuilding for a shop or for yourself, if you're just putting most street transmissions together, you're going to use for most cases just a standard OE style friction material. Here's kind of a different groove patterns you might find in clutch packs. That I wouldn't say this is exhaustive by any means, but their design, the manufacturers come up and says, we feel that this is the best design to fit how we're applying this clutch pack to best distribute the oil that is running through this clutch pack for the best application possible. That's essentially what it is. You're not going to have necessarily control over this because you're going to buy clutch packs or clutches that are designed for each clutch pack for each transmission, because there's no universal here. It's not like you go, well, these clutches will fit all these transmissions, so I can just buy these clutch discs and then I can put them in all these different transmissions. Most transmissions are going to use different clutch discs because they're designed specifically for that transmission. Our apply and backing plates. The apply and backing plates are thicker steel plates used in clutch packs. The apply plate is the thick steel plate that goes against the piston. So when the piston engages, it pushes on this apply plate, which then pushes on the other steel and fiber discs in there, which then applies the clutch pack. The backing plate, which is, I think in your book, they're calling a pressure plate, is this thicker steel plate that's on the other end of the clutch pack next to the snap ring in most cases. Okay, so they're basically sandwiching these steels and fibers between two thick steel plates. Not all clutch packs have a thick apply plate. A lot of times what you will see is the apply plate is just one of the standard steel plates. A lot of times in these clutch packs there's waved plates in them, and we'll talk about those here in a little bit. But for this idea, when we're talking about apply and backing plates, these are the thicker plates on each end of the clutch pack. The apply plate is going to be next to the piston, where the backing plate is going to be next to the snap ring in the drum. Okay. The idea is if we have solid surfaces in there, we can better squeeze and hold that clutch pack together. Here is kind of a picture of that, of a clutch pack, how the fluid goes into the drum, into the back side of the piston to push the piston out and apply the clutch packs. At the bottom of that screen you'll see your clutch piston. On clutch pistons, I talked about how these pistons will have seals on them. A lot of times these pistons will be aluminum. But as we're seeing in more newer transmissions, you're seeing this more and more, the piston has the seals molded onto it. So when you rebuild transmissions, you have to make sure you get those pistons also. A lot of your older stuff, you just took the piston out, replaced the new seals, put the piston back in. On a lot of stuff now, they're going to where you have to replace the whole piston because the seals are molded into them. A lot of times these pistons are just a thinner cast steel piston, and then we use that to apply the clutch pack. Then you have your spring assembly, and then the snap ring holding the spring assembly in. Remember I talked about that you have the big snap ring on the outer edge holding all your clutch plates in, but you need a way to hold that piston and spring assembly in place where you run the risk of the piston coming out of its the smoothed out area in the drum, and then the clutch pack won't apply, and we'll have fluid leaking by, and we'll have a pressure loss. Then you can see we have a waved plate. A lot of times these are just a thin steel plate that is waved or beveled, and we'll talk about that here near the end of this. And they're using that so to help cushion the apply of that clutch pack. Again, most customers don't want that transmission to shift really hard. They don't want to feel that shift. So they try to smooth these shifts out to kind of dampen the torque as they apply, so it doesn't shift so hard. And then you can see the alternating steel and friction plates. In this, they're calling the apply plate the reaction plate. Either way, most rebuilders call it the apply plate. And then they alternate steel, fiber, steel, fiber, steel, fiber. That's how we get a clutch pack. The more discs that you have in a clutch pack, more fiber discs, or the bigger they are, increases your holding power of your clutch pack. Determines how much torque can be applied through that clutch pack. If I have much bigger clutch discs, but only 3 or 4, that might hold just as much as a smaller diameter clutch pack that has 6 clutch discs in it, because we're still getting about the same amount of surface area. In the most cases, this is not adjustable how many clutches you put in a clutch pack. they're set at the factory. But there are some cases to where you can change this. You can, if you want to beef up the strength of a transmission, you can put more clutch packs in it. A good example of this is the GM 700R4, you call it the 4L60 or the 4L60E. They have a clutch pack in there called the 3-4 clutch pack. It's applied in 3rd gear and 4th gear. Those were notoriously weak part of that transmission in the early days, and they would burn up pretty easily. So companies came out with kits. A lot of times they would hold 5 or 6 fiber clutches. A lot of companies came out with where you could put 8 or 9 fiber clutches in there. That increased the holding capability of that clutch pack. So when we're talking about operation, we've talked about a little bit. We're going to take hydraulic pressure through our passages in our transmission or valve body, depending on when we want to get a shift, depending on which clutch pack we use, which holds certain gears. And when we get into diagnosis, we'll go through what we call clutch and band charts, clutch and band application charts. So we can look and say, this thing's slipping in 2nd gear. What clutch is supposed to be applied in 2nd gear? So I could know which direction I should be looking if I'm going to take that apart, what I should be finding in there if something's burned up. Or it might help me lead to maybe a shift valve not moving. But we'll talk about that more when we get into the diagnosis. But each transmission is going to be different. They're going to call their clutch packs different names. Whether we're going to call it a direct clutch, a forward clutch, clutch A, clutch B, clutch C, clutch 1, 2, 3, front clutch, rear clutch. As you can see, each manufacturers have different names for their clutches. So we be a very long class to try and come through here and list out every transmission and what each one of their clutch packs is called. And again, when we're talking about planetary gear sets, I was talking to you about we could go in and go through how each clutch transmission uses its clutch pack to direct power flow, but that's going to differ through the transmissions. So it's best to just understand that the clutch packs and bands are used to hold or drive different parts of the planetary gear sets, and that we can look that information up depending on whatever transmission we're working on. But in other words, getting back to how we apply our clutch packs, we apply fluid into the back side of the piston. This piston then is able to move in a smooth section of that drum. That piston moves out and pushes against these fiber and disc plates, and it squeezes these plates together. So you're essentially taking these clutch packs and squeezing them in like a sandwich. That locks that drum, because remember, our steel plates are lugged or splined into the drum, and our friction material is splined onto a gear or another drum. So when we lock that clutch pack together, we are then taking that drum and locking it to another drum, to a gear, and that directs the power flow. When they no longer, and when we do that, that's when we get another shift, depending on which clutch pack we use. Then when we want to downshift, or we don't need that clutch pack applied anymore, the pressure is released from the back of the piston, and the return springs push that piston back to its rest or unapplied position. There are some transmissions that also apply pressure on the front side of that piston to help push that piston back. Again, it's just for an assistant to release that piston faster, so we're not trying to hold a clutch pack longer than we should. And then we're going to here it says that we talked about this, the two types of clutch packs. We have holding or braking clutches and driving clutches. Remember, we have to hold one of those members of the planetary gear sets, and then we need to drive or apply the other another member of the planetary gear sets, and then the third member gets turned into our output. Here's a good picture of how a clutch pack works. As you can tell, on the inner part of that is some sort of gear or one-way clutch, which we'll talk about here in a minute. And the fiber clutches, the friction clutches, are splined onto that on the internal grooves, where the steel plates are splined into the drum itself. So fluid is applied through the oil passage under the underside of that apply piston. That pushes the piston out, and as you can see in the upper picture, there's space between the frictions and the steels. That means that drum that the steels are lugged into can turn separate from that inner gear that the frictions are splined into. But as soon as we apply fluid pressure, it pushes that piston out, squeezes those fibers, clutches, and those steel plates together, and now we're locking this drum on the outside to that inner gear or inner sprag or drum, and then the two turn together. Okay, and this is how we get power flow through the automatic transmission. And then when it releases, the return springs push that piston back into place. If you look on the outer side of that apply piston, you see a little black, looks like a V-shaped thing on the this picture. That is actual, you'll see it on the outside and the inside of that red apply piston. Those are your lip seals. That keeps fluid pressure from moving past the piston, and then you lose fluid pressure, the piston doesn't apply, and either the clutch, you don't get a change of gear, or it tries to apply but not very tight, and then the clutch pack slips. That's why older transmissions, if those lip seals get old and dry, fluid pressure is able to leak by, and the clutch pack doesn't apply, or it doesn't apply very tight, so the clutches, it actually slips. Instead of holding tight, the outer drum is going to want to move or slip and not hold that inner gear tight. If we get low fluid pressure for some reason, maybe get low on fluid, or we get a leak in the system, pressure regulator valves not working properly, anything that would keep us low pressure is going to do the same thing. This is how we get what we call slipping in a transmission, and we'll talk about that a little deeper when we get in diagnosis. Is for some reason these clutch packs are not holding tight together, and it could be just as simple as age, and the friction material is wearing off our fiber discs. Here's a picture, and that picture before was a apply clutch or a driving clutch. Here's an example of a holding clutch where we have a clutch pack, but the steel plates are lugged into the case. The piston on this one is below what we can see below the clutch pack. Sometimes the piston will be on the drum that we're fitting on top of that as we're sliding it in. But either way, to be a holding clutch, your steel plates are going to be lugged into the transmission case. And then your fiber clutches will be splined onto a drum or a gear set, something that we're sliding into that clutch pack. And then we can lock, when we apply that clutch pack, we lock the inner member to the transmission case and it holds that. It becomes a reaction member of our torque flow. Now that we've talked about clutch packs, we're going to talk about bands. Again, I'm really urging you guys to watch these videos. You know, that's a requirement, but it would be real easy to get in there and just fast forward through these videos. But these videos are very helpful to where we can see in person what these clutches look like and understand a little bit more about how they work. Because this is kind of if I'm going to make an analogy here, if our pump is the heart of our transmission, if the valve body is our brain, the clutch packs and bands, our planetary gears, these are like our muscles and our bones. This is what does the actual work in the transmission. So when these clutch packs and bands start to not hold, that's when we start getting slipping, improper shifts, maybe what we call sloppy shifts or soft shifts. So it's very important that these components are working properly, and it's important to understand how these components work. So now a band, the basic purpose of a band is to prevent the rotation of a drum it's wrapped around. These bands are going to be wrapped around some sort of drum. Sometimes they'll even wrap around the ring gear of a planetary gear set, and they'll hold that ring gear to get the power flow that we need. And again, the drum can hold a clutch pack, or it can be a member of the planetary gear set. This band is supplied hydraulically by using a servo piston that travels in a machine bore. We talked a little bit about this when we were talking about accumulators, how that softens the apply to these servos. And we'll talk a little bit about how these servos work here in a minute. And then the other side of the band is anchored to the transmission case. Remember, if we're going to hold something, we're holding it and locking it to the case. So the band has to have some place where it's anchored to. And we anchor it to the case, so when we apply that band, we're locking that part of the planetary gear set or the drum to the case, and it becomes a holding device. Here's a kind of a pretty common picture of a band. You can see where the band will wrap around what we call the high reverse clutch drum. In this case, it holds, when we apply that band, it grabs and holds that high reverse clutch drum. And then that drum is tied into, as you can see, a sun gear, input shell, and a rear sun gear. It's tied into the planetary gear set. Types of bands. We have a rigid band, which is just a single thick heavy band. We get a flexible band, which is a single thin light band, and then a heavy band, which is a split double wrap band. The heavy band is going to be able to have the most holding power. It's going to have the most friction material on it, and then probably your rigid band after it, with your flexible band being the weakest of those bands. But you're going to see all three of these different types of bands in a transmission. A good example of some older transmissions, this double wrap band that's used in the low reverse of a Turbo 400. A thin, light, flexible band that is really common in a lot of transmissions. That would be a band in a 4L60E, what they call the 2/4 band, and then this heavy band, single thick band, that would be the second gear kick down band of a Turbo Hydromatic 350. Those are just different examples where you might find these bands at. Now when we get to servos, these are what actually apply the band, because we have to have an anchor point and an apply point. We need to be able to squeeze this band together to hold that drum or that reaction part of the planetary gear set. It's going to have a cylinder that the piston rides in, and then we're going to have a rod or a pin on that piston that pushes on the band itself, and then we need a way of returning that piston, and we use a return spring to return that piston in its rest position when we no longer want to apply that band. Here's some pictures of our different band designs, and starting from left to right, your split double wrap band, your thick single wrap heavy band, and your light single wrap thin band, and the holding power, the amount of torque that they could hold, kind of goes from left to right, from high to low. Your double wrap band is going to hold the most, then your thick single wrap, and then your light single wrap. The friction material we use on our bands is going to be very similar to the friction material we find on our multi-disc clutch packs. It can be paper, it can be Kevlar. Some will be completely smooth, some will have grooves in them. It's going to be very similar, and depending on the material, depending on the design, will depend on how much torque that band will hold. Some bands have adjustments to them. The adjustment, there's not very many bands that are adjustable. When we go over service the transmission, we'll talk about adjusting bands. But if the band is adjustable, in the sense that you adjust it when you service it, we adjust it because we want to take up this clearance. Clearance between the band and the drum, the more clearance it has, the longer it takes to apply, which could lead to long and soft slit shifts. But if you have it too tight, it could drag and burn up the band, or it applies too quickly and you get a real harsh shift that the customer will complain about. But the anchor point, if it's adjustable, that is where they'll have a bolt and a nut, lock nut, and we can turn that bolt in or out and adjust that clearance on that band. Some bands don't have that adjustable nut, but the apply rod that actually applies the band, that rod can be of different lengths. A lot of times you would have a special tool that you can measure what size rod you're supposed to have, and then you put in the proper size rod that servo applies and applies the band. In most cases, in the vast majority of cases, that if you have a non-adjustable band, but you can change that rod, it's a selective size. In most cases, if you don't change the case itself, you just reuse the rod that came with it. Rarely do you have to go in there and actually measure that and change that selective size rod. Here's an example of kind of how a band is anchored and applies. One example of it, as you see in that top picture, you can see where the anchor is actually an adjustable rod or bolt. You would loosen that nut that's around that, because that's the lock nut, and then you turn that screw, it's threaded into the case. Then you would turn that stud in or out a certain amount of turns, and then you lock that nut down. And those specs you'll find in your shop manual. The servo apply piston, they're going to apply pressure on the back side of that piston. That piston's going to push out. It's going to push on that rod, which is going to push on that lever, which is then going to squeeze that band and make it grab the drum or the planetary gear set. There's going to be a spring on the inside of that servo that when they release the pressure on the back side, that spring is going to push that servo back closed. In some cases, just like on clutch packs, along with that spring, they'll apply pressure on the other side of that servo to help it release. Because we want to release our clutches. The release of clutches is just as important as the application of the clutches. If we have a clutch that doesn't want to release or doesn't want to release quick enough, we're going to have shifting problems in a transmission. Here's an example of this one's not adjustable. The linkage rod, it says graduated. That's a selective apply rod that you could measure and say, no, I need a different size apply rod. In shift kits, a lot of times it's not odd to get into shift kits and they tell you how to modify that rod to get a better shift with the band. But as you can see on the right side, the anchor point, it's anchored to the case. It's not adjustable. And then they apply pressure on the back side of that piston, which pushes against spring pressure, which pushes the linkage rod in and applies the band. There will be pressure on the inside of that. That's our accumulator pressure, if you remember, in most cases. So it actually dampens how fast that servo piston applies. So we kind of talked about the operation already. Fluid enters, pressure enters the backside of that servo. The servo piston moves out and tightens the band around the drum. When the band releases, not only do we have a spring in that servo, the elastic nature of the band itself helps push that servo out and helps the band spring back out of place. If the band didn't have a springy nature, even if the servo piston backed out, the band wouldn't spring back out of place. So it would drag on the drum, or the servo rod that applies it could come out of place and then fall out or something silly like that. But there's a reason those bands have some sort of spring nature to them, so they can release and move away from the drum. And that servo piston can be released by either spring pressure and or hydraulic pressure. Now I'm going to say this, I've never seen a servo piston that didn't have a spring in it. Again, as we've talked about classes, about the time you say that, a transmission manufacturer calls you a liar and builds one without a spring in it. But the important thing about those springs can break, and then you don't have proper application of your band, because again, that spring helps control how fast that servo piston applies. But for the most part, to release them, they have a spring, and on some systems they actually use hydraulic pressure to help push that piston back and release that band. Here's just an example of a band applying. In the top one, it's applied in second gear. There's pressure on the back side of the piston, as you can tell. On this one, it looks like the actual apply rod is adjustable. Vast majority of them, the anchor is what's adjustable. But they're applying fluid in on the back side of that servo piston, and then when it goes to release, the spring is pushing that piston back, and you can tell they're putting pressure on the front side of that piston to help release that band. Now we're going to talk about one-way driving clutches. Again, we talked about this on overrunning pulleys, on alternators, and our starter drives. This allows a rotation of a device one way, and in a transmission that's usually clockwise, but locks it in the other way, and in most transmissions that's counterclockwise. When we're talking about one-way clutch packs, applying and holding in a one-way clutch is referred to as holding or being effective. So when they lock a one-way clutch, when they hold it with maybe a clutch pack, that means they're saying, and we'll see this when we're looking at clutch and band apply charts, they'll say that one-way clutch is being effective. If it's released and is allowed to freewheel, it is being called ineffective or non-effective. That's important to know when we're looking at clutches and band charts. Two main types of one-way clutches. You got our roller clutch, and that is where we have a smooth race, which can be the inner or outer race can be smooth, and then the other race is going to have a ramped surface to it. Okay, and there'll be a series of rollers and springs in this to help lock this into place. And I have a picture to kind of help demonstrate this. Here's one way. That's a good picture to show you the smooth. In this one, the inner race is smooth, and you can see the rollers with the springs. And on the one side where it's freewheeling, the rollers are moved away from the surface and allows it to freewheel. It's not locking the outer one to the inner one, where when it's locked, it locks the two together. My next picture shows that a lot better. As you can see, when we're holding this or locking this one doesn't show the picture of the springs, but the springs are going to be up near where those notches are. And what it's going to do is it's going to push that roller down into the narrower part of that ramp. So when our outer race in this case, or the inner race turns, and it drives that roller into the narrow part of that ramp, it locks those two together. Then, when the races turn the opposite direction, it pushes that roller against the spring up into the larger or deeper section of that ramp, and now the two pieces can turn independently of each other, and that's the freewheel position of a one-way roller clutch. The next type we call sprag clutches. These, both the inner and outer races are smooth. There's not ramp surface. But what they use is a series of sprags that are mounted in a special cage. The sprag is almost looks like an hourglass, the shape of it. And in the picture, I'll show you how that works. If you look one way, when it goes to, as the inner race, you can tell, turns, in this case counterclockwise, it takes and it turns these sprags. As you can tell, they're not a perfect hourglass, but what it does is it turns these sprags and then it locks. And when it locks or wedges, then the two pieces turn together, the outer and inner race. When the inner race turns clockwise, it actually pulls the sprags to where they move away from the outer race. So now our outer race can turn separate from our inner race. And that's how we get these one-way roller clutches or one-way sprag clutches. These are used in different circumstances depending on how we want to control torque flow through a transmission. A lot of times they're used that when we accelerate a vehicle, the one-way clutch is engaged, and then we get up to a certain speed and we just let off the gas, we haven't shifted a gear, then even though the momentum of the drive shaft has slowed, inertia in the drums of the transmission, they want to keep turning. So with the drums and the input or output start turning in opposite directions, and so then the sprag is allowed to freewheel. It almost goes like into a neutral position. So if you're driving a truck, and you usually get this in lower gears, say you're in second gear trying to pull a load and you're getting it up to a higher RPM and you let off the gas, that allows that transmission to freewheel and kind of eases up on the wear in the transmission, and it almost goes into like a neutral position. But as soon as you apply driving force back to it, it would turn the races in the different direction and would lock the sprag in place or lock the roller clutch in place. Now we're going to talk a little bit about shift quality. This is important when we get into diagnosing transmissions. Basically, how smooth the transmission shift is referred to as shift quality or shift feel. When we were talking about accumulators, we were talking about slide bumps where the accumulator slowly engages and then locks real tight right at the end. Or you can get a transmission that has a real short shift and harsh shift, or a long drawn out shift over a long period of time. All these can lead to, say, a long drawn out shift can lead to a slipping or sliding condition, which is hard on the clutches. A real short shift or harsh shift, the customer is really going to feel. So Shift quality in a transmission is extremely important. Your manufacturers go through a lot of trouble to make sure that that transmission shifts in a way to where customers won't complain, but still has longevity and life to that transmission. We could make a transmission shift really, really soft and smooth to where the customer may not ever feel it, but it shifts too slow and it doesn't apply enough pressure, and it burns those clutches up in our clutch packs and burns our bands up pretty quickly. We can shorten the shifts and make them really harsh to where maybe the clutch packs might last for a long time, but it really jars the vehicle. You're applying a lot of torque quickly, and customers are going to complain about that. About the only time you want real short and real harsh shifts is in race applications. This is where we're going to tie accumulators to bands and clutches. We've talked about this. We're absorbing some of that pressure buildup, some of that fluid during the pressure buildup stage. When we apply that clutch and band, we're softening the application, lengthening it out just a little bit. Nothing wrong with that as long as it's done correctly. We don't get too short or too long of shifts. Another way we do it, this is where our waved or bevel plates come into play. It takes more pressure to compress a waved or bevel plate, or more time. So we use those waved or beveled plates to where the clutch pack applies slower and smoother. These are often called cushion plates. We do this so we don't get a real harsh engagement. A real common clutch pack is, in many transmissions, they're called the forward clutch pack or the front clutch pack. There's a clutch pack in most transmissions that as soon as you put it in a forward gear, it locks this clutch pack. So anytime you're in a forward gear, this clutch pack is always locked. And that's almost always the one connected to the input shaft of the transmission. So we're always getting power from the impeller, the turbine of the torque converter through the input shaft. So the clutch pack hooked to that input shaft is always engaged, especially in forward gear. So we put a cushion plate. That way when we get in the car, start it up, put it in gear, we don't get a real hard bang when we put it in gear. Almost all your low reverse clutch packs, so when you put it in reverse, have these beveled or waved plates. So we get a cushioned application, so we don't get too harsh of a shift engagement. That's the main reason we use a waved or beveled plate in a clutch pack. Here's kind of a picture. You can see these are just steel plates, but they're just not flat. Definitely on that wave plate you can see, and these wave plates can have a different amount of wave to them. Some can be a real severe wave, and some can be a real light small wave. Just depending what the manufacturer determines is the best plate for their clutch packs for their transmission. Here is a beveled plate that I was talking about, a little better picture than the one before it. As you can tell, the inner diameter of the plate sits at a different level than the outer diameter, so it's beveled. That's where we get our name from. This, again, these types of plates are used to help cushion the apply of our clutch packs. And if it has these plates in there, you got to be careful on how we check clutch pack clearance. Our section on automatic transmission service and repair, we will go through just the basic disassembly of a transmission and how to rebuild it, how to test it, and so forth. Okay, to summarize through all this, as we talked about, the power flow through a gear set is controlled by our driving and reaction devices. In other words, our apply and holding devices. These are our clutch packs, our roller clutches or one-way clutches, and our bands. We got to hold and drive different parts of the planetary gears to get our different gear ratio sets. And like we said, the primary holding or apply devices are the multiple disc clutch packs. Our one-way clutches, again, we're in review here, are primarily used to hold planetary members in reaction, but they can also be used with multiple disc clutches as a driving device. But they need a multiple disc clutch in use with them to be a driving device. And then bands are to hold planetary members in reaction. And then the timing of the apply devices has a direct effect on shift quality. Our timing is our shift from, and the timing and the quality is that shift from gear ratios. These are our speeds of our transmissions. How smoothly, how well those shift from one gear to another is important, or we're going to get customers complaining if it's too harsh or if it slips. Now that we're done with our clutches and bands, again, I urge you to watch the videos. These are important. Help you understand and see first hand exactly what these things look like. Make sure we're taking the quizzes. Make sure we're reading in our books. After this section, we're going to get into transmission electronics and how to diagnose transmissions. Diagnostics between how it shifts, determining whether something's slipping or maybe shifting too hard. When we talk about electronics, we're getting the scanner out, making sure all our electrical solenoids and speed sensors are operating correctly. We're going to look how to diagnose the hydraulic system by checking pressures, and we're also going to look at clutch and band charts, to where if we have a transmission not shifting correctly or not shifting into certain gears, we can look at a clutch and band apply chart to see what clutch is supposed to be holding, what band is, what solenoids are supposed to be operating, and so forth. So until the next lesson, see you then.